So we are working on some trigonometry, and we've discovered that there's a little formula we can use to connect the ratio of two sides, the fraction that we make of two sides, with a particular angle size. Our calculator is really helpful for that, and up in the top corner of the screen we've got the formula that we've been using, tan x equals opposite over adjacent. So we've learnt to name our sides, we'll continue to do that, and we're going to keep using this formula. But this time, instead of trying to work out the length of a side, I'm actually going to try and work out the size of the angle. Now you'll notice that in this problem here, I know two sides and I don't know the angle, rather than in the previous problems where we knew an angle on one side and tried to work out the other. Because the formula, if you look up at that top part of the screen, because it's got effectively three elements to it, we've got x as the angle, opposite is one side and adjacent is the other. We're always going to need three bits of information here, and usually we know two, and we're trying to work out the other one. So as long as we've got two pieces of information for that formula, we can always work out the third one. So we're trying to work out the size of angle A. It looks like it's an acute angle, so we're hoping that our angle will be less than 90 degrees. In fact, it's almost less than 45 degrees, but we'll see how it works out. So what we do is let's name our side. So we're hopefully quite good at that already. We've got across from the right angle is the hypotenuse, HYP. Now the named angle, or the stated angle now, isn't a number. We don't know it, but we still regard that as if there were a number there. So across from the marked angle is the opposite side, and then the other side is still the adjacent side. So that's the three names that we're going to use, and we can go ahead and actually write down our formula, which is tan x equals opposite over adjacent. So we go ahead, and actually still fill in all that we did before. So there's no change to the process here. But this time, the angle x here, we don't have the angle. We would normally write in the number there. So we have to write in A. That's our angle name. Tan A equals, now the opposite is 4, and divided by the adjacent is 8. So in the past, we've had a letter in one of these fraction places, but this time we've got both the numbers. So what that does mean is we can actually work out a decimal value for that. So instead of rearranging it, we're just going to rewrite tan A on the left, because we can't do anything with that. But we are going to take our calculator and do 4 divided by 8. Okay, well, you know that 4 over 8, or 4 divided by 8, is a half. But what we're going to do, rather than write it as 1 over 2, we're going to write out as a decimal fraction, because we're going to use our calculator. If most of the time you're probably going to have to round your decimals, as we'll see with the next example, and we try and round it to about 3 decimal places, but sometimes like this you'll come across a more exact fraction, and that's absolutely fine. So what we need to do is to work out the angle, so that if you press the tan button, it would give you 0.5. Now you could go ahead and try and guess the angle that gives you 0.5. So for instance, if I do tan 25 on my calculator, tan 25, I get 0.466. Okay, 25 degrees, tan of 25 is 0.466. That's quite close, so that suggests that I should actually go up a wee bit. Let's try tan of 27 degrees. So tan 27 is 0.509. So my answer is going to be quite close, probably somewhere in between the likes of tan 26, which is just below. So it's going to be around between 26 and 27 degrees. Okay, so you could do it a bit like that, trial and error, but your calculator has a much better way of doing it. What we're trying to do is to undo the tan. We want to remove it from here, but it's not like it's not multiplying. We can't divide by tan to get rid of that. What we need to do is to apply the inverse operation, and for trigonometry, that inverse operation is called the inverse tan, and it's got a little -1, which we'll learn about a wee bit later, means 1 over, or the kind of the inverse fraction. So we're going to call that tan with a little -1, and we write in the number 0.5. And our calculator if we use the inverse tan, is going to be told work back. If we know the fraction, tell me what the angle is. Okay, so what you need to do is you need to find your tan button, and that's fine on your calculator, but you'll find that on top of it, the invert or the shift function, the second function, you should see a little tan -1. Have a look at it. It should be written just above the button, tan -1. So the way you get to that, of course, is to use the button that's either kind of second function or it says shift somewhere on your calculator. And if you do that first, okay, you do shift and then press the tan button, you'll see on your screen the tan with a little -1 coming. So you do that and then you put in the number 0.5 and you should get an answer that's roughly between 26 and 27. So if I do shift tan 0.5, I get the answer 26.565. 26.565. Now again, I don't usually give the whole answer. I'm going to round it to one decimal place, which is 26 point, well, the 6 here tells me to round the 5 up, so I'm going to do that. It's degrees, because this time it's an angle, so it's not centimeters, it's degrees, so our answer is 26.6 degrees. Okay, so we've got a slightly different way of finishing it off. The good news is we start off exactly the same way, but what you really need to do is to learn how to do the inverse tan function on your calculator. Okay, so make sure you can do that. Let's have a second example here. Calculate the size of angle X in this right angled triangle. So we've got a right angled triangle, so it means we can use our right angled trig formula. Opposite the right angle is the hypotenuse. Opposite the marked angle is the opposite. And the other one is the adjacent. Our formula that we've been learning is tan x is equal to the opposite side divided by the adjacent side. Okay, so fill in all the things that we know. Tan x, well, that should be the angle, which is still x in our diagram, so this time we don't actually change it, it stays tan x. The opposite side, looking carefully, is 1.7, and the adjacent side is 0.9. We can't do anything with the left-hand side, but we can take our fraction, because we know both the numerator and the denominator, and we can do 1.7 divided by 0.9, and that gives us the number 1.8888, and so on. There's a wee 9 at the end, but it's basically 1.88888. Now, this is really important, so listen. You don't want to round that to one decimal place to make it 1.9. That's going to make too much of an error on your final answer. Because all these numbers are really close together, the tangent numbers, it's really important to distinguish between them. We've got to go right as far as about there, to about 3 decimal places. So in this case, if I want to round my ratio, I'm going to have to use 1.88, and then this 8 that I'm cutting off is obviously bigger than 5, so my answer, I'm going to use 1.889. Okay, so always round your ratio to 3 decimal places at least, if you're going to round it at all. So here we've got tan x is 1.889. So to get x itself, I need to do the inverse tan, and that's my tan with a little -1, 1.889. So take my calculator, I'm going to press the shift button and the tan button, and that's going to give me the tan -1 on my screen. I put in 1.889 equals, and I've got 62.104. Okay, now this is the final answer. By all means, round it to 1 decimal place, but don't do it earlier than that. So the angle x is 62.1, I'm rounding down, degrees to 1 decimal place. Okay, so that's how we find the angle if we know 2 sides in a right angled triangle. Okay, so here's some practice questions. There's 6 questions on the screen here. I want you to work through these and try and work out the answers for the angles that are marked, and you can, I'm going to work through the answers. So you can try the first one and then check my answer to that. If it's okay, try the second one, check my answer, and then just kind of then work through the other ones. Okay, so this is your chance to work ahead of me, and you can use my solutions to check. Okay, so pause the video now. Okay, so hopefully you've done at least the first one. Let's have a look at that. So we've got hypotenuse, opposite, and adjacent. And we're using the tan ratio. Tan x equals opposite over adjacent. So in this particular triangle, the blue one, the angle is marked x, so we keep tan x equals, the opposite is 5, adjacent side is 11, so I've got 5 divided by 11. Now, because I know both the numbers on the fraction, I can take my calculator. 5 divided by 11, 0.4545. 0.4545. If I round that, I'm going to round it to 3 decimal places, remember? So that tells me to round up. So tan x is actually 0.455. That's the number I'm going to use. I need to undo the tan function, so the inverse of tan x is called inverse tan, tan to the power negative 1 of 0.455. Take my calculator, shift tan 0.455 equals 24.465. 24.465, and so on. I just want to round it to 1 decimal place, so I'll cut it after the 4. 6 tells me to round up, so I've got 24.5 degrees to 1 decimal place. Okay, so let's try the next one. If you haven't already done so, go and do that first. Right, let's get a wee bit of colour here. So here we go. Hypotenuse. Now this marked angle's up at the top, so the one down at the bottom is the opposite side this time. And then we've got the adjacent side. Okay, so let's see, let's change the colour here. So what have we got? We've got tan x equals opposite over adjacent. So what we've got, we've still got x as our angle. Tan x equals, the opposite is 7.5, adjacent is 12. Take my calculator and work out that 7.5 divided by 12 is 0.625. Okay, it stops there, so I don't have to round it. I can use all of that. I can then say that to get x itself, I have to do the inverse tan function, inverse tan of 0.625, which on my calculator, shift tan 0.625 gives me 32.005. 32.005, and so on. When I cut it, that's clearly going to give me just 32.0. Don't drop the 0. If you're rounding it to 1 decimal place, keep the 0.0 there. We could say it's just 32, but I'm going to go 32.0 degrees to 1 decimal place. Great. And then the last one we've got here, there's the hypotenuse. A is the angle, so that's the opposite side. And then here's the adjacent. A is, this time, if you notice, is the bigger of the two angles. It looks like it's bigger than 45 degrees. And that what you'll notice now, that if the numerator is bigger than the denominator, you'll get an angle bigger than 45 degrees. We'll learn a bit more about that as we get familiar with it. So let's just check. Tan x equals opposite divided by adjacent. Now this time I've called the angle A. So sometimes we change the letter, and that's fine. The opposite side is 37, and what have we got? Adjacent is 12. Now you notice here the numerator is bigger than the denominator, so that's going to give me a number that's got 1 point something rather than 0. 37 divided by 12, and it's 3.083. I just meant it's bigger than 1, okay? So, oops, let's get rid of that. Oh, let's just stop that a minute. Right, tan A, what did we say? 3.0833333. Okay, so I'm going to cut it after 3 decimal places. That 3 tells me to round down, so I'm actually going to use 3.083 tan of A. Okay, so the angle A itself is inverse tan of 3.083, and that's going to give me shift tan 3.083 72.029. 72.029. I'm going to round it to 1 decimal place because it's my answer. A is equal to 72.0 degrees to 1 decimal place. There we go. So make sure you keep the angle, the marked angle in the diagram. It says A, so try and use A and not just assume it's going to be X, although it often is. Okay. So let's try the next 3. If you haven't tried them, why don't you pause it and give these a go and then check with me as I do them. Okay, formula. Substitute in, this time the angle's D. Calculator, 5.2 divided by 7.6, 0.684 2, and so on. I'm going to round it to 3 decimal places. So I get 0.684. Okay, therefore, angle D is the inverse tan of 0.684. According to my calculator, inverse tan 0.684, 34.372, 34.372, dot. Round it. Well, after the 3, the 7 tells me to round up, so it's 34.4 degrees. Okay. This one here, the brown rectangle. Let's try and see the brown triangle. We've got, I'll change the colour, hypotenuse. We've got this N is up there, so that's the opposite. I've got adjacent, just keep it in red to make it separate from the black. Tan X is opposite over adjacent. This time it's tan N, and we've got 4.2 divided by 6. 4.2 divided by 6 is exactly 0.7. Again, you sometimes get numbers like that, and where you don't have to round them. N is the inverse tan. Oops. Excuse me. N is equal to inverse tan of 0.7, and according to my calculator, that would be shift tan 0.7, 34.992. 34.992. I cut it to after 1 decimal place, and the 9 says round up, which of course means that we have to bump up 2 digits, 35.0 degrees to 1 decimal place. And lastly, but not any leastly, let's try the blue one. Hypotenuse, opposite, adjacent, and we can say here that the formula tan x equals opposite over adjacent. This time the angle is marked x, so we keep that in. Opposite is 2, 4, 5. Adjacent 65. We've got an improper or top-heavy fraction, so that I'm predicting my angle is going to be bigger than 45 degrees. It's going to be closer to 90. 245 divided by 65 is 3.7692. If I cut it after 3 decimal places, the 2 tells me to round down. So I've got 3.769, which means that x is the inverse tan of 3.769. And that's going to give me inverse tan of 3.769 is 75.140. 75.140. Oh, that was a very big eraser. Let's rewrite a little bit of that in. That should have been tan to the negative 1 of that. It's what did it say? 75.140. Cut it after 1 decimal place. Its x is 75.1 degrees to 1 decimal place. There we go. Hopefully you've got all of these correct, and if you didn't, hopefully you're picking it up as we go along as to where the mistakes were made. Okay, great job. We're going to go on and explore maybe some of the other ratios in trigonometry now that we've kind of covered all that we need to know with the tan ratio. So let's go on ahead if you're ready.